So, what did we do last week? Yeah. And the one, so we looked at bar charts, we looked at pie charts, we looked at how to do them in 3D, and to do a 3D pie chart, we had to install a package first. Yeah, so R comes with certain functionality, but there are lots of packages out there that give you additional functionality, and you install them once. Once you install them, you can just type library and the name of that package. If you've never used them before, you type install package first. So for the pie charts, we used a package called plotfix. So the first time you want to use it, you need to install it. Did anyone try it at home? Anyone tried plotfix at home? No. Okay, but it's pretty straightforward, and today we look at another package again, so you'll see the whole process again. So we did bar charts, pie charts, and in the end I showed you box plots, which is where the lecture from a few weeks ago became useful again with quartiles, median and mean, and I talked again about that sometimes we prefer the median, yeah, sometimes we prefer the mean, so it depends on whether we got a more normal-like distribution, you know, that famous, no, does it work? If you've got a distribution, a normal type distribution, this is a bell curve or a Gauss distribution, whatever you want to call it. Let's say this could be grades in the class, you know, here are the best grades at this end, here are the worst grades. If you've got any kind of normal distribution, normally people like the mean, but sometimes median is better. For example, we could have lots of outliers. So last time we had, we had some outliers. But of course, if those outliers are very far away, let's say all our data is here. Let's say, I don't know, income in this room, and let's say one of you won the lottery yesterday, yeah, and then suddenly, you know, they have lots of money there, and suddenly that would shift our traditional average quite a bit. So sometimes we prefer to look at the median, where we basically say how many values are smaller than this number, how many values are bigger than this number. And if we just count, you know, how many students have more in their bank account, how many have less in their bank account, then we often get a more normal number. So it depends on what's more suitable for your data. But we can see those numbers in the box plot. And we also saw that outliers are being marked, so that the default was 1.5 the quartile range, you know, the area between the first and the third quartile. And let's just reconstruct that from last time. And after we reconstructed that, I'll show you another chart that I think is useful because it shows a bit more than the box plot. But funnily enough, even though I think it can be more useful, it's not that common, but I'll show you in a moment. So let's do student age again. I could find the old one on my hard disk, but we got a different mix of students today. So I want all our student ages in here. I want to create a vector. So what do? Or actually, instead of typing it in the console, let's start an R script, and then I can always go back. So, and I'm lazy, I just copy and paste, cut and paste in this case. Okay. So how do I get the age into the vector? You've done that stuff often. Student age is where I want to store the different ages. So who's 18? Hands up. Who's not 18? One student with 18. So we want to put the first element in. So somehow 18 should go in. Let's start typing. How many are 19? 2. Yeah. And so on. So how, if I hit enter, will this work? No. So how do I get them in? C, yeah, very good. Very good. Okay. And 2 times 19, who's 20? How many are 20? 21? 22? 23? Last time we had a number, didn't we have an age with a few people were a certain age? Okay. So instead of typing 19 a few times, there was a way of basically writing a number repeatedly. Web, yeah. So how did web work? Let's try it here. Web. We say what we want. Yeah, let's say 19, and let's imagine for argument's sake there were 8 students, or 8 students with that age. Is that how it works? Should I try it? Yeah. So just say I want to repeat the number 19 8 times. Okay. So let's just use that again, just to remind you of it, of how it works. So we got 2 students who are 19 years old. Who's 20? How many are 20? 1? Okay. How many are 21? Only 1? How many are 22? Only 1? How many are 23? Only 1. How many are 24? 25? 1, 2, 3, 4, 5, 6, 7. Well, there are quite a few who don't want to give their age away. Should we leave it? I need some more data. You can make it up, but you know, there won't be much to look at in terms of box plot if we stick to that. 19. Are you one of the 2?
No.
Let's do it again with your participation. And if you don't want to give your age away, just make one up that's half believable. Otherwise we don't have much of a box plot to draw. So 18, hands up.
Me.
You. 19. 2 of, okay, 20. 21. 2, okay. So, 22. 23. 24. Okay. Should we put our age in again?
Yeah.
Yeah, because I want to show outliers and stuff. So let's put that in again. Well, I think last time we had nicer data to work with, but let's stick with that for now. And then if it looks too odd, we can still put some additional numbers in. Pretend there were more students today. Yeah, where is everybody? There's supposed to be twice as many as that, at least.
Just increase some more numbers now.
Yeah. Let's look how this box plot looks like first. So, should I send this off? Does it look okay? Yeah, let's try it. So instead of just pressing enter, because I'm here in the R script file, I go to the line I want to send off and I press Control and enter. Yeah, and that will send it off to the console. So here we are. How do I get a box plot? Box plot, yeah, good answer. Box plot, and I want box plot of student age. What do I type? Box plot, student age. Okay, this is how it looks like. So last time, we had one of your classmates called it box and whiskers, and she said she used the terminology in school or in college or wherever. So at the moment we don't even see the this horizontal line here at the top because of the way our data distributes. Yeah. Let's have a look. Student age. Yeah, so this is what we got in there. Okay. Well, it's not great, but let's work with that for now. So the one new type of plot I want to show you today is called a violin plot. And violin plot, I think has the advantage, and there'll be examples where there's a bigger advantage than in this example. But we can imagine now. There's a lot here. So here's the middle. Here's the first quartile. Here's the third quartile. So if we imagine the distribution, if we think back, do we have any volunteers who might want to draw how the distribution might look like? So 19, 20. What was the oldest age of the main bunch of students? 23? 23. 23. So based on the box plot, we think it could look somehow like this, yeah? And then there's nothing for a long time, and then we got 2 high values in here. Yeah. But based on the box plot, we just have to imagine how this distribution looks like, yeah? We don't know how exactly it looks like, yeah? All we know is here's the median, first quartile, third quartile. We don't really know how it distributes in there. And here we have our outliers. The Violin plot helps us sometimes to understand the distribution of the data better. And the package is called Vioplot. So I want to install a new package. Anybody remembers how to install a package from last week? Have a guess. What could the command be called to install a package?
Install package.
Yay! Look, and I just keep typing. I just start typing. And as usual, RStudio has this autocomplete function, and it already suggests a few commands for us. Install packages, installed packages, and install R. So install packages, and I said it's called Vioplot. So let's see what happens. I'll send it off. Yeah, installing package. Successfully downloaded. Yeah, so it should be there. Okay, so from now on, unless I restart my machine, unless I reinstall my machine, from now on, Vioplot should be on my machine. So next time I want to use Vioplot, I don't need to install it. I can just add this package to our library. Anybody remembers the command? Yay! Library. Here we are. And it's called Vioplot. Let's send it off. Loading the required package. Yeah. Okay, so now we can use the command called Vioplot. Vioplot. So let's try F1 to get the help file. Produce violin plots for the given grouped values. So we give it a vector, and we get a violin plot. Oh, something else to mention. I don't think I mentioned it last time. If you've got data, and if you want to see some sort of exploratory plot to try to understand the data, usually you can just type plot, and R will try to pick a suitable way of plotting this. Yeah. So if you're not sure, should I try bar chart, or which kind of plotting should I pick, you can just try plot, and whatever you want to look at. Let's see what plot student age. So what does it come up with? So when I do plot student age, yeah, and now it picked a scatter plot. Plot, let's try the help. Hi. That should here generic function for plotting of R objects. For simple scatter plots, this will be used. So okay. Can we add your age to our student age vector? Would you volunteer your age? Then I add it to the student age vector. You don't have to. 21, thank you. So one more who's 21. Okay, let's run the whole thing again. Box plot. Yeah, now it looks a bit different. Okay, so we wanted to try Vioplot now. Vioplot student age. Okay, let's send it off. And well, in this case, I'm not sure it looks much better, or because now you kind of get the impression that there are cases here that there are students who are 35. So you know, sometimes certain plots are better than others. If you look at plots, you know, why are we looking at plots? We're looking at plots because we as human beings can interpret the data faster. Yeah. If I look at, and I mentioned this last time, but let's look at the box plot again. Now this box plot here doesn't have any more information than this line of numbers. In fact, this box plot has less information because we don't really know what's exactly going on here. But still, if I look at a bunch of numbers, you know, I have to think about it actively with my brain. Whereas if we see diagrams, if we see plots, our subconsciousness is helping us process this information. So here immediately we see, oh, there are two very high values. And when we know how box plots work, we can see most of the stuff should be here. Yeah. But we see the white space, immediately we notice that there are some dots here, you know, that are not anywhere else in this white space. So that helps us understand, once we know what a box plot is, that, you know, here are all our numbers and there's some extreme values here. Whereas if we look at those numbers, it might take us a bit longer to figure that out. And imagine there were 1,000 numbers. It would take us quite a while to figure out where are the high numbers. Whereas if we turn 1,000 numbers into a box plot, we'll have a very fast way of grasping, in this case, how the data distributes. So there are two different reasons why we produce diagrams and plots. One of those reasons is that we want to understand the data better for ourselves. Let's say, you know, you're working for a company and they're selling things, and you want to look at how do the sales distribute over the year. Then maybe you'll figure out, oh, you know, before Christmas we sell more, surprise, surprise. But maybe for whatever reason in March there are more sales and you didn't expect that. So we can see, we can help explore the data set, we can try to understand trends in the data. Another reason why we want to produce plots and graphs and diagrams and so on is that when we want to communicate this information, and if you remember, this module is called data communication. So you might work for a company, you might look at the data, and you might want to then tell your boss or your colleagues or people under you how things went. So you might want to produce diagrams. First you explore the data, you want to find trends, for example, or whatever you might want to find. And once you figured out what you want to figure out, you know, if you work for a company, that might not be good staying in your head alone. Your colleagues, your bosses, your people under you, whoever, might also need to know about it. So you might want to use diagrams to explain the data to other people, you know, which is then when we have to label the axis properly and maybe give it some nice colors and make it easier to understand. So the violin plot I would think in this case not that useful, because I think it misrepresents the data. Suddenly I think, there's students here, there are quite a few students that are around 35, and there are a little bit more students in their 40s. So not always a good representation. But we could fine-tune how this plot is being drawn. So there will be plot. There will be options here to influence how the plot is being drawn. And if you think back of the box plot, there were also options, box plot, how the box plot is being drawn. For example, the range we talked about, everything outside that range will be listed as outliers. So we could influence where do the outliers start and so on. Of course, if you had bad intentions, you could use the whole thing to misrepresent data. But obviously you don't want to do that. You want to represent the data in the most meaningful way, for example, for your company. So if we think back, if we look back at the Violin plot, we are kind of seeing how the data is distributed. And there's a function called density. Let's look at that. The kernel density estimation. So it basically helps us understand how data is distributed. So I want to calculate the kernel density estimation for student age. And I'll store it in something, I'll just call it D, because I can't think of something better than that. There are all sorts of numbers in here. And now let's try plot D. And look, earlier I used plot. When I used plot earlier, I got a scatter diagram. But now I use plot, and because the data we are handling is different kind of data, a plot will give us something else, not a scatter diagram. So in this case, we can see how our data distributes. A very similar diagram would be a histogram. Histogram, the generic function hist computes a histogram of the given data values. Let's look at the histogram of student age. It's kind of similar. We can see there are values here in the 40s. We can see there are lots of values here. And in this case, look, it's labeled frequency. So a frequency of 1 means 1 student. So in this case, we can see how many students are there between 45 and 50. Have a guess? 1. How many students are there between 15 and 20? 4. Now, I didn't tell the system to pick 5 years as the interval to choose. Was that a good choice from the system? Yes? Who thinks it's a good choice? Hands up. Who thinks that there are much better choices available? Okay. Can you tell me the problem of having picked 15 to 20 here? I see one problem. Yeah, and the other problem here is, this is a university. You're first year students. I haven't seen any 15-year-old first year students. So this range here that the computer picked, and 5 seems like a good thing to pick. If you ask, how old are my customers, and you want to produce a histogram, and your customers range from, very young to 100 years old, 5 might be a good number. But I think in this case, maybe 5 isn't a great number, because, the youngest person here is 18. So, most, or basically everybody in this first bar is actually completely at the top end of that range. So you can fine-tune the whole thing. But just to do a simple thing, I can basically say how many breaks do I want, how many bars do I want. Breaks is 20. Is 20. Let's look at the histogram help first before I send that off. F1. Yeah, breaks. So you can give a vector with the breakpoints, or a function to compute the vector, or a single number giving the number of cells for the histogram. So I could also hand over, I want 18 to 20 and then 20 to 22. Maybe sometimes for whatever reason you want to have some wider than others. So let's send the whole thing off with 20. And now it looks different again. So it's up to us, especially when we want to explain it, to try to represent the data in a clever way. But in the end, if you look at this histogram, and if we look back at the plot of the density, look, they look quite similar. Just one is bars, one is kind of, round lines. And in the end, if we look back at our Violin plot, our Violin plot doesn't look so different than a 90-degree turned version of this kind of histogram. But sometimes, you want to use a bar chart, a pie chart, whatever it might be. But keep in mind what I said in the past, that people normally think that humans are better to judge length than volume. So many people will say pie charts are not a good idea, because if you have a pie chart with lots of small values and lots of big values, it's much more difficult to understand how big the difference actually is. Whereas if I show you a small bar chart and a very long bar chart, it's easier for us to judge. Okay, there are some nice data sets built into R. There are lots of them. There are lots of data sets here where you can practice your skills. So there's lots of medical stuff in there. Monthly death from lung diseases in the UK. Average monthly temperatures at Nottingham, 1920 to 1939. So there are lots of different types of statistics that you can use to try things out. So I thought I'll use some of those today to give some further examples of box plots initially. Okay. So the library you need to load, library is called datasets. So if you load the datasets library, you got all those datasets from the web page just before available to you, and there's one of them called World Wide Web usage. It's called www usage. And if you type a question mark first, then you will get, did I send this line off? Then you will get an explanation. So this is internet usage per minute, a time series of the numbers of users connected to the internet through a server every minute. Yeah. And this has been taken from this, probably a book, time series analysis. Yeah. So if we go back to that web page, here it is, internet usage per minute. Okay. So let's have a look at the data in www usage. Yeah, and here we are, it's a time series. Yeah, it starts, we basically have 100 values. So it's the number of users connected through a server. So when people looked at this server, the first minute they looked at it, 88 people were connected. And a minute later, 84 people were connected. A minute later, 85 people were connected, yeah? And so on. So what we can do is box plot. And then internet usage. And look, this data is to some extent similar to our student age, but because there are more numbers, there are 100 numbers now, it's more difficult for us to understand just by looking at the numbers. So using box plot, yeah, will help us understand it better. So our average was somewhere here. First quartile starts around 100. Third quartile starts around, what's that, 170? Here we got our highest and our lowest value. So, most times there were around 130 or so users. Most minutes, 130 or so users connected to the server. Do you remember how to get some information like the first quartile, the third quartile, and so on printed on the console? Let's try it. Some of the, yeah. So the minimum 83, first quartile is 99. But when you look at the picture, you are not really sure. Is it 100 or what is this? At least I'm not. Maybe, you can judge those things better. Some people are better than others. Median, mean, and in this case, I guess the whole thing is normally distributed. So median and mean are quite close to each other. Third quartile, maximum. Let's do a violin plot. What do I type in? Yeah. Yeah. I should have pressed Control Enter. I just pressed Enter. Yeah, here we are. And now it looks like, actually the numbers go down, but then at the bottom, it's getting a bit busier again. Can you use the other things we used earlier with our student age to try to get a better idea? Yeah, what else did we do? We did histogram and we looked at the density. Should we try one of those? Yeah. So imagine you work for a company and your boss says, oh, I don't know if you ever have a technical work, our server is busy. Let's have a look, what's normally the usage of our web server. Or let's say you're working for a restaurant and you record how many customers come in your restaurant at what time. Yeah. Then you can see here, imagine those were customers at a really big restaurant. Yeah. And sometimes we've got more than 200 customers in the restaurant, or let's say department store. Yeah. Sometimes it's a low number. So whatever data it might be, whether it's users on the web server or visitors in your store, or whatever it might be, this might be data that you might want to prepare to show to somebody. Should we try density or histogram?
Histogram.
Histogram. Okay, how to do it?
Test.
Hist. And then?
One very loud music.
Yeah. Okay, let's send it off. Yeah. And look here. We can see, and we can't see that at the box plot. Let's compare it with the box plot. If I look at the box plot, I might assume this is completely normally distributed. And the fact that the median and the mean are quite close together also might give me that impression. But when I look at the histogram, when I explore the data a bit further, I can see here that there are lots of minutes when it's quite unbusy. In fact, when they're less than 100 users, we got lots of minutes with less than 100 users. We've got most minutes with less than 100 users. Should we use the break function? Maybe if we use the break function, we'll discover even more. How many cells do we want? 100! But they're only 100 minutes. Okay, let's do that for fun. Useful? Yeah, you think so? Good. Yeah. And again, the data looks quite different again, because yeah. And now hopefully, it might have still grouped things together, to be honest, because if we look at, should we try 200 for fun? No. Yeah, but we still see that there are lots of times when the server wasn't very busy, but sometimes the server is quite busy. Yeah. Imagine this is your department store or your restaurant, and let's say it's a restaurant, and sometimes it's really busy. Then the next step might be maybe trying to figure out when is it busy, because at those times you want to maybe employ more staff. Now, if this is based on a real-world problem, then of course there would be people on the floor with that kind of experience anyway. Yeah. But if you're the Tesco manager, you don't have the experience that the shelf fillers have. Maybe the shelf fillers know that every time before a football game they need to refill lots of cans of beer, because people all buy a 6-pack of beer to watch with a football game. But if the manager in the high office wants to know, he needs to figure that out from data. I think big companies wouldn't have a chain that feed this kind of information up. Yeah. But whatever trends are there that actually might be available, might be knowledge somewhere in your company anyway, you might have to figure out from this kind of data. Yeah, and this is always the problem with big companies. And I mentioned the Xerox example at the beginning of the year when we talked about knowledge management systems. That there was this fault with the Xerox machines, and then one of the engineers figured out how to fix that photocopier. But how can they distribute that knowledge within the company? So this all links very nicely together. In this part of the module, we'll look at how to analyze data. We want to get meaning out of it, but actually, once we have some sort of meaning out of it, maybe we need to distribute that meaning in our company. That might be done, for example, with a knowledge management system. Okay, there's another nice example here, which is called air miles. No, not air miles, air passengers. Here we are. Monthly airline passenger numbers 1949 to 1960. So this is a so-called time series. So that's something that can be part of R. So let's have a look. Summary. air passengers. Yeah. Now we see a time series of monthly airline passengers, 49 to 1916. So the maximum, so there was 1 month where they had 622 passengers. In the least busy month there were 104 passengers, and on average, yeah, depending on whether with average you mean mean or median, it was 265 to 80, something like that. Passengers, yeah, and this is the data. So this is a time series. We got the month here, and we got the years here. And this is again one of those examples. You're looking at it. Does it make sense to you? Can you see any trends in this data? If you look long enough, you probably can find out a few trends.
Busy all the time.
Getting busier all the time? Yeah. Like here in the 60s, there are higher numbers than in the late 40s. But look here, for example, November, December. November we got a lower number than in the summer, for example. Okay. If we work with time series, there's a function, there's a command called cycle. No? So that basically gives us the position in the cycle. I'll just show you how that works. Yeah. So we need that for another statistic in a moment. So basically cycle will tell us, oh, January is the first cycle in that year, February is the second cycle in that year. So I'm just lazy and copy that into my clipboard. Now I do a box plot, and I want to show the air passengers and how they distribute over the different months, over the different cycles. Yeah. So now this is looking at it. So what are we seeing here? What does 1 represent? January, but which year?
What time is it?
All the Januaries, yeah. So in this case, I'll send that off again, yeah. So in this case, we are thinking, is there something going on that certain months are busier than others? And in this example, I'm saying, I look at all the Januaries and so on, and how does it look like? Which months are busiest?
Sorry, what is it?
Which months are the busiest month for the airline?
Summer?
Yeah, looks like it. Looks like it. So we can interpret, we can explore data using different kind of diagrams, and we can try to see whether there are certain trends in there. Yeah. You've seen, overall it gets busier, but now we can also look at other different trends. Are certain months busier than others, independent of the year? Any questions? Okay, I'll leave it at that.